Okay, guys, welcome back. Now we are going into part two. Part two, all right. So we're looking at the board. Part one is done just now. So part two, I'm going to introduce to you something different. Now, in previous class, we have learned that this is called voltage or potential difference. Potential difference, all right, or volt. The simple word is volt. Now, in this case, whatever volt you give, example, if volt is 12 volt here, the voltage, so we call it potential difference. So the 12 volt is going to be supplied to the resistance here. So now, if you were to put a voltmeter here, and if you were to put a voltmeter here, the reading will be same. That means reading across the battery is 12 volt. That's what the battery is showing. And the same 12 volt is going to be supplied to the resistance here, the resistor here, and this is also going to show you a 12 volt. This is the basic, all right? But in this case, we are assuming that the battery, the cell, is perfect battery or ideal battery, which means there is no loss of any form of energy inside the battery. So ideal battery. However, in most cases, it is not like that, all right? Now, in most cases, some amount of energy, power is lost inside the battery. It is due to what we call as internal resistance. Okay, internal resistance. So that means now something new is coming up. Here, just now, in the previous video, we never discussed internal resistance. So if you don't have internal resistance, you are to use a direct formula, which is Ohm's law, direct. However, if there's an internal resistance, then we need to use this formula. Now, if there's an internal resistance, the potential difference, we don't call it potential difference, let's give it another name. It is now called E. Sorry for my E, E looks different because there's too many E's. E stands for energy, E stands for so many other things. So therefore I'm going to use this E so that we don't get confused. This is called EMF or electromotive force. Electromotive force. What's the meaning? Electro means electron. Motive means motion, push, force. Force to push the electrons to move. You get it? So what's actually voltage or potential difference? The potential difference is actually the force which enables the electrons to move. EMF. Are you clear? All right, got it. Now, that means now, in this case, assuming now the E is 12 volt. So the sum of the 12 volt will be used up inside the battery because the voltage is needed by this resistor, internal resistance. You get it? Which means now part of it is being used up here, which means whatever balance will be supplied here. So you will see that the voltmeter here, if you connect a voltmeter here, it will not show 12 because part of it has been used inside. Which means here it might become 11.5 volts. You getting it? Now why 11.5 volt? Because part of it has been used inside here. So how much has been used inside here? Inside here, balance of 0.5 volt has been used to overcome this resistor inside this battery. Are you following me? So therefore, when you add up both, you're going to get 12. Now, assuming this is now 6, let's give a number now, right? Okay, let's put 5 ohms. And let's say the internal resistor is 1 ohm. Okay, so what is the total resistance? The total resistance is 5 plus 1 is 6. So this formula now can be modified. I'm going to erase this off. This formula can be modified as I R plus R. Same thing, when you expand, you get back the same formula. Am I right? So therefore, 1 plus 5. 1 plus 5 is 6. Here is 12. 6, 12, divide. You're going to get current flowing through here. Current flowing through here is going to be 2 amperes. Are you following me? All right. So let's do that. So that means if I ask you, what's the reading over here? What's the reading over here? 2 2 ampere is flowing through here, 2 ampere. So let's use this formula now. I'm using this formula because it's only this part. All right. So therefore 2 times 5, only 10 volt is being supplied here. On the other hand, so 2 amperes moving here, and over here, what's the internal resistance? It's 1. So since 2 times 1, V equals to IR again, V equals to IR. So I is 2, R is 1, 2 times 1, you're going to get 2 volt is actually used up inside here. So total is 12. Are you following me? All right. So this is something new which you need to learn. All right. Now I'm going to erase this off. Now the next thing which might be asked here is something important. Please take note. If I were to put a voltmeter here, so the voltmeter, although the battery has got 12 volt, remember, 2 volt has been used up, which means the voltmeter will only show the balance which is available for outside, which means the reading here will not be 12, but it will only be 10 volt. Are you okay? So that means when the current is flowing, But let's say now I open up this switch, and so current is 0. That means when current becomes 0, because my switch is open, so no more current flowing. When there's no current flowing, you don't need to overcome this resistance anymore. You don't need to overcome this resistance anymore, which means the 2 ampere is not available anymore. There's no current. This resistance you don't have to overcome anymore, which means the 2 volt you don't have to overcome or don't have to use inside the battery, which means now the voltmeter here across the battery is going to show you 12 volt back again. Why 12 volt? Because the 2 volt is not being used. Now, since there's no current flowing here, when there is no current, when I is 0, the voltmeter V1 is also going to be 0 because there's no current flowing. So when there's no current flowing, you don't use any volt. So similarly, there's no 2 volt is not lost inside here. Why? Because the current is not flowing. You understand? So what do you understand here? When there's no current, it shows the EMF. What's the EMF? The complete voltage when there's no current. But when there is current, the voltmeter here will only show after you minus the internal voltage loss. Are you clear? So this is what you need to understand. So this is where the formula comes in. So the formula can be written like this: IR plus R small r. All right, sometimes they will write IR plus small r, internal, same thing. Or they might just write V plus IR. What is V here? V is the available voltage for the external circuit after you minus off the internal. This is the internal voltage. Means the available voltage for the external circuit. This is for voltage lost internal circuit, internal battery cell used. So I want you to understand this formula. So this formula is something new. Are you okay? All right. So make sure you are clear. So once you are clear, then I will take you into part 3. Thank you. Good.